Okay, hello everyone. Okay, we meet again in transition element topic. Okay, for today I will explain about another general properties of transition element. Okay, so I will focus on formation of complexes. Right? In nomenclature of complex compound, okay, it's the most important that to identify the complex compound which is cation, neutral or anion. Okay, because for central metal, if the complex compound is cation or neutral, the name of central metal is same. Example, if the central metal is chromium, so we use chromium in naming. But for anion complex, the naming of complex will end with ATE. Example, chromium, it will become chromate. Nickel will become nickelate. So this is the naming. So this is all is about central metal. We must elect this thing. So here is the list of transition metal that naming for anionic complex. Like aluminium, we convert to aluminate. Beryllium become berylate. So this both is group 2, group 13. And then we have titanium become titanate. And until copper, cuprate, zinc, zincate. So this name is only available for anion complex only. Now let's try do the example. So here is the complex compound. So what is the central metal name? So here is a cation complex since it has 2 plus here. 2 plus. So this is the cation complex. So since it used the copper as a central metal, so we name it as copper. Because this is the cation, so same name. Second one example. Now we have so we have a second example here. If you can see that it has 4 minus charge, so means that it is the anion complex. So what happen is you must name the central metal which is iron here as a ferrite here, ferrite. So we must use ferrite in naming the second compound. The third one is, here is the example of complex which consists of more than one types of ligand. So now, this is the compound. So this complex compound is a cation. Because sulfate is anion, sulfate ion. So this is the cation. So that means we use the same name of central metal. So we just use cobalt in naming the compound. Right? The fourth. So this is also the complex compound. Since sodium is a cation, so this complex ion is a anion. Right? Anion. So the right side must be anion. So what is the nickel name? Nickel name here, central atom name. Because this is the anion, so we must put ATE for nickel. So looking to this table, nickel is become nickelate. So for this compound, we must use nickelate in naming the compound. Now we go to the step, in doing the nomenclature of complex compound. The rule of IUPAC naming coordination compound are as follows. So the first one, cation is named before complex anion, just like we do earlier. So Greek prefix di, tri, tetra, penta and hexa are used to denote the number of ligand bonded to central atom. So for anionic ligand, The suffix O is used where a neutral ligand is called by the name of molecule. Okay, exception, water, CO and ammonia become aqua, carbonyl and amine. Okay, the name of central cation is followed by its oxidation state. Right? Okay, and then if the complex is negatively charged, the naming of complex ion will end with ATE. Okay, like Benedict, chromate and so on. Okay, and then the ligand name is alphabetic order. This is the important thing. We must follow alphabetic order. Okay. Okay, and then base, tris and tetrakis are used to replace di, tri and tetra if its ligand already has prefix. This one we will do example after this. Okay, this is the example of naming the ligand. Alright, so in naming the complex compound, we must use this formula. Okay, starting from prefix of ligand, okay, followed by ligand's name. Okay, and then we put central metal name, followed by oxidation number. So this is the order, okay, in naming the complex compound. Okay, so now I want to show you how to calculate the oxidation number of central metal. Okay, the first step in before we naming the complex compound, we must calculate first the oxidation number in central metal. Okay, this is the example of complex compound. Okay, let me calculate how to calculate the oxidation number of copper here. Okay, so this one, so copper, okay, which is aqua is a 0, neutral ligand, so 0 here. Okay, and then positive 2, so equal to positive 2. So copper is a positive 2 oxidation number. Okay, second one, okay, example here. Okay, we have iron, okay, which is cyanide, okay, which is cyano as a ligand, and the complex ion is a 4 minus. So what is the oxidation number of iron? So, okay, because cyano is negative 1, okay, complex ion is negative 4, so iron is we get positive 2. Okay, third example here, okay, so we have chromium as a central metal, and here is the bidentate ligand, okay, oxalate ion. Okay, and then the compound, the ion charge is a negative 3. So, okay, what is the charge of chromium? Okay, the oxidation number of chromium. Okay, we get positive 3. So, you please try to calculate it yourself, yeah, class. Okay, the last one is this is the example of compound which consists of more than one type of ligand. Okay, it contain of aqua, it contain of chloro. So, okay, we have nickel. So, what is the oxidation number of nickel? So, since aqua is a 0. Okay, and then chloro is a negative 1. Okay, so this is the neutral compound. Since it has no charge here. Okay, this complex compound have no charge. So, equal to 0. So, finally, nickel is equal to positive to oxidation state. Okay. Okay, now, okay, this is the example, okay, of the compound that I want you to try to naming yourself. Okay, but before that, we show some video here, okay, in naming the complex. Okay, some example. Okay, so let's enjoy the video. Let's rename the first complex ion. Alright, so for the first step, okay, before we name it, okay, you must make sure that to calculate the oxidation number of the complex. Okay, for the first question is actually is a cationic complex, which is a positive complex. Okay, so this is how we calculate. Okay, copper, okay, water, which is aqua, we know that is a 0. Okay, 0 equal to positive 2. Okay, so copper is positive to oxidation state. Alright, so, okay, for the first thing, when we want to name this is the prefix of ligand. Okay, the ligand in this ion is water, aqua. So which is the prefix here is 6. So we start naming, okay, by put the prefix, okay, hexa, okay, water, okay, is aqua. So hexa, aqua, okay, the central metal is a copper. So since it is a positive cation, so we no need to change the central metal name. So we just put copper. Okay, and then followed by oxidation number, which is 2. Okay, so put Roman. Right, so settle for the first question. Hexa, aqua, copper, 2. Okay, for third question, okay, this is the anionic complex, which is anion complex. Alright, so let's calculate the oxidation number first. So iron, okay, plus 6, okay, Cn is a negative 1, okay, equal to negative 4. Okay, and then iron equal to negative 4, okay, plus 6, okay, plus positive 2. So iron is a positive 2 oxidation state. Right, so okay, so the ligand here is cyanide, so we convert into cyano. Okay, so the prefix is hexa. Right, so naming start by hexa cyano. Right, okay, and okay, since this is the anion complex, so we must convert the central metal name, okay, which is this is the iron, so we must convert into ferrite. Okay, so hexacyanoferrite, okay, oxidation number is positive 2, so we put 2 Roman here. Okay, so settle. Question number 5. Okay, if you can see that this is the anion complex and the ligand involved here is bidentate ligand. Okay, so this is the bidentate ligand. So for bidentate ligand, alright, so the name is, okay, what is the name? Okay, its name is oxalate, okay, or ethane diowato. Okay, ethane diowato. And if you can see that, okay, in the ligand name, if you can see that it have di prefix. So we must put the is, right, to represent the numbering, the prefix of the ligand. Okay, so calculate the oxidation number here. Okay, chromium. Okay, so because of this is the bidentate ligand, so it have charge of negative 2 oxidation state for oxalates, okay, equal to negative 3. Okay, and then chromium equal to negative 3, okay, plus 6. So chromium is positive 3 oxidation state. Okay. Okay, now let's name the complex ion. Right, so starting from prefix of the ligand is a 3. Okay, but since this ligand is already have a prefix, so we must put 3s. Right, so 3s. Alright, okay, and then ethane diowato. Okay, ethane diowato. Alright, okay, and then followed by central metal. Since it is an anion, so you must convert into chromates. Okay, chromates. Okay, and then its number, oxidation number is positive 3. Okay, so 1, 2, 3. So this is the name of the anion complex. Okay, for question number 7, okay, if you can see that they have more than one types of ligand. Okay, it have aqua here. Okay, it have aqua. Okay, and also it have chloro. Okay, chlorine. Okay, convert into chloro. So the name is chloro. Right. Okay, so it have 2 different ligand here. Right, then, okay, we start to calculate the oxidation state. Okay, so for this kind of complex, if you can see that they have no charge here, no charge. So means that this is the neutral complex. Okay, so this is the neutral complex. So, Okay, nickel plus, okay, aqua is a neutral ligand, so plus 0. Okay, so, and then chloro to -1. Okay, chloro is a -1. Okay, and okay, this is the neutral complex, so equal to 0. Okay, and then nickel, okay, equal to positive to oxidation state. Okay, we start to name the complex, neutral complex. Okay, so for the ligand, okay, which ligand must we put first? Okay, so since this is the we must follow the, okay, in naming the ligand, okay, we must follow alphabetical order. So since this is the A, so we must put aqua first. Alright, so for, okay, so tetra, the prefix is tetra, aqua. Okay, tetra, aqua. Okay, dichloro. Okay, dichloro. Okay, okay, and then this is the nickel. Since it is a neutral complex, so just use the same name. Okay, so nickel. Okay, so put the oxidation state, which is 2. Okay, so the name is tetra aqua dichloronickel 2. Okay, for question number 9. Okay, this is actually the complex compound. Okay, which is this complex is a cation complex, right? And this bromide is a anion. Okay, because this is the compound. Alright, so, okay, just like we use the normal compound like NaCl, alright? Okay, so, okay, let we write the cation here. So, PT, okay, NH3, 5, Cl, okay, so what? Okay, so the charge of the cation is 3, positive 3, alright, since Br 3. Okay, so now is, okay, so name, okay, since it have more than one types of ligand, so this is amine. Okay, this is chloro. Okay, so for, remember for the alphabetical order. Okay, then, okay, calculate the oxidation number first. So, PT, okay, plus 5, okay, ammonia is a neutral ligand, so 0. Okay, plus negative 1 of chloro. So, equal to positive 3. Then, platinum is equal to positive 3. Okay, plus 1. So, positive 4 oxidation state. Okay, right? Okay, then, okay, let's name the compound. Okay, okay, the cation compound. So, actually, this is the cation complex. Alright, so, okay, so, okay, amine, chloro, so we must choose amine first. So, this is 5, so penta. Okay, penta, amine. Okay, penta, amine. Okay, chloro, 1 only, so penta, amine, chloro. Okay, penta, amine, chloro. Okay, because this is the cation, so we just use the same name of central metal. Okay, so which is platinum. Okay, so chloroplatinum. Okay, chloroplatinum, and oxidation state is positive 4. So we just put 4 in Roman. Okay, so this is the name pentaamine chloroplatinum 4. Okay, so how to name the compound, the overall compound? So this is the cation only. Okay, so this is bromide. So pentaamine chloroplatinum 4. Okay, this is all without space. Okay, but okay, for anion, we just put 1 space and become bromide. So this is the overall compound name, pentaamine chloroplatinum 4 bromide. Okay, so I hope you will understand what I show you just now. Okay, so here is the answer lah. Okay, the answer in naming. Okay, the complex compound, and so the other compound I want you to do yourself. Right?